Hello, my name is Ellison Heil, and today I would like to talk to you about restoration in Appalachia through a visual and literary analysis of ecological disturbance and restoration potentials in the Central Appalachian coalfields. Appalachia is a geocultural region that follows along the Appalachian Mountains of the eastern United States. The study region focuses on Central Appalachia, which consists of eastern Kentucky and Tennessee, southern West Virginia, and southwestern Virginia, and is highlighted on the map as a coral boundary. This region is characterized by extensive coal mining. In order to understand what the future holds for this region, we must first think about how we got here and begin by looking at our reference ecosystem in the form of old growth forests. What exactly were early colonizers seeing when they first stepped foot into these forests? And then from there, we can think about the history of resource extraction in the region and how timber harvest and coal mining were linked. And then how technology ramped up the scale of these operations to where we are currently in mountaintop removal. How are we working with federal guidelines to reclaim these mountains and restore forests? And lastly, as we enter the United Nations Decade of Ecological Restoration, how can we progress current methodology to better improve these regions? The virgin mesophotic forests of Appalachia stretched well over 10 million acres and were characterized by rolling hills and numerous hollows, and were among the most biodiverse ecosystems on Earth. This biodiversity is the result of complex topography comprised of narrow ridge lines with steep slopes on either side and countless streams in between. These old-growth forests provided a suite of biodiverse understory species that provided sustenance to local indigenous people. We can call this the ecological base, and the baseline of which communities relied upon. An easy way to think about this is through a Cherokee word called Uganost, which is a noun for wild, sweet spring greens that were essential to replenish restores after a hard winter. And while I would love to sit here and talk about the flora of this region, there's three charismatic species which maybe you recognize on the left side of the graphic that I'd like to present. And those are the American chestnut, Castanea dentata, ramps or Allium trichocum, and the king of Appalachia, the American ginseng or Panax quinquefolius. And those alone sell for hundreds of dollars per pound. And it's important that we think about these understory species and the sustenance that we provide as we begin to think about restoration in the region. A timeline of the loss of this ecological base begins in the post-Revolutionary War when revolutionary elite claimed ownership of immense tracts of Cherokee, Choctaw, Chickasaw, Seminole, and Creek Nation land, but deemed it to be too steep and remote for cultivation and left it alone. Communities of Highlanders and pioneers settled the region and claimed land through squatters' right and lived off the land similar to indigenous people in relying on the ecological base. With the turn of the century and the Industrial Revolution, the invention of the steam engine fostered the development of the bandsaw and the shay-geared locomotive, which sparked commercial logging. These two machines operated in concert to enable access and transport of timber in large volumes from remote and treacherous wilderness to lumber mills for efficient processing. And with the outbreak of the Civil War, the reconnaissance and cartography expeditions in Central Appalachia, both before and during the Civil War, gathered extensive amounts of information. As cartographers scouted out the region in order to draw battle maps, they noticed rich outcroppings of coal seams, and the synthesis of this information as maps was critical in conveying the prospects of this frontier to potential investors. In the 40 years that commercial logging operated at full capacity from 1870 to 1910, over 10 million acres of virgin old-growth forests were clear-cut. Deforestation of the Appalachian forest stripped away the region's ecological base that provided the foundation of indigenous nations and subsistence agrarian livelihoods. To make matters worse, the aftermath of logging left behind slash, which easily caught fire from sparks produced by the steam-powered locomotives and sawmills. I would like to highlight a region in West Virginia using archival photography called Blackwater Canyon, where a virgin old growth forest was timber harvested and left to become desolate and fire stripped in the bottom right. And we need to remember that these forests weren't adapted to fire, as it wasn't part of their historical disturbance regime. And then alongside the cartographers mapping out the area, and as they began to relay this information to investors, they realized that the boom of commercial logging created this network of railroad infrastructure, and they coincided with this to significantly increase the accessibility to mining regions. And while this extractive process in the beginning had low ecological disturbance, it became to realize that it had a high human toll and was extremely dangerous for the miners that were going down into the mines. And since 1900 has caused more than 100,000 deaths. And as we began to realize the human toll on this process, we also started to see the environmental toll take shape in the form of acid mine drainage, which refers to the outflow of acidic water from a mining site. These exposed metals within the mine dissolve into water and flow into waterways, poison downstream waters, and impact the livelihoods of those communities which rely on these waterways. And so, in order to get away from the dangerous human cost of going into shaft minings and the advent of new technology, surface mining began stripping away huge tracts of forest and understory vegetation to expose the soil covering coal deposits. This soil was known as overburden, was then extracted with heavy machinery and discarded in piles called spoil. The underlying coal is then extracted and the mine area is reclaimed after mining operations have finished. Mountaintop removal is the most ecologically destructive form of surface mining, as the extractive process removes all vegetation and highly productive biota and topsoil, and drastically changes the area's topography. To understand this, let's think about it in three components. First, we have our heavy machinery, where developments such as the dragline radically increased mining productivity and scale by enabling a few machinery operators to work safely and at an immense landscape scale. They were scooping up large amounts of overburden and dump them into dedicated excess spoil deposit sites known as valley fills. These valley fills were causing a lot of soil deposition downstream, and in order to remedy this in 1977, federal law required sites to smoothly grade and hydroseed with competitive herbaceous vegetation to create a barrier to hold down that soil. But unfortunately, this also created a barrier against recruiting of native species from the surrounding forest and inhibited the growth of planting trees, therefore arresting secession towards a climax community. In order to get a sense of the scale of this operation, I've created a time lapse over the course of 32 years using satellite imagery to get a depiction of what an mountaintop removal operation looks like. So where are we currently? How are we approaching these old mining sites and getting forests back onto them? The current methodology follows the Forestry Reclamation Approach, which is a prescription for effective post-coal mine reforestation and restoration of ecosystem services that can be applied under the Surface Mining Control and Reclamation Act and is compliant with its regulations. It falls under the Office of Surface Mining. It's researched by the Appalachian Regional Reforestation Initiative and is carried out by various NGOs such as Green Forest Works. It's a 5-step process that starts with creating a suitable rooting medium, loosely grading the topsoil instead of compacting it, selecting native and non-competitive ground covers, planting early succession and commercially valuable trees, and using proper planting techniques. As we transition into this new decade and understand that ecological restoration is an intentional activity that aids in an ecosystem in recovery, I want to view these areas through the lens of Hobbes's novel ecosystems, how they are new, non-historical configurations of different species and interactions and functions owing to a variety of local and global changes. This implementation of theory is a response to Appalachia's habitat and biodiversity loss, drastic topography and resulting hydrology changes, watershed pollution, as well as a rapidly changing global climate. Through understanding that this is a blank slate mentality, we can start to view this area, and I would like to present the concept of an Uganost cooperative. For far too long, if Appalachian coal barons and local community members seen economic disparity and a gap widen over time as a result of society's overemphasis on resource extraction. Post mining landscapes provide an opportunity to bring back the ecological base while also creating economic opportunity for the region. So I propose that we progress current methodology away from commercially valuable crop trees and decolonize the landscape and bring back those Uganost understory species. I want to engage local community members as stewards of the land by returning the landscape to a public commons and retrofit existing infrastructures such as railroad grades to be more sustainable and provide ecotourism opportunities such as hiking and biking. And lastly, fund this through federally funded grants such as the Abandoned Mines Minelands program to create a local food cooperative which facilitates land stewards to harvest and forage Uganost for the local community and tourism sector by marketing a home-cooked meal as a sustainable, traditional, forest-to-table experience. Thank you.